Question 23. In an imaginary water filtration process, a fraction of 1 over n of an impurity is removed in the first pass of the water through the system. In each succeeding pass, the amount of impurity removed is 1 over n of the amount removed in the preceding pass. Show that if n equals 2, the water can be made arbitrarily pure, but if n equals 3, at least half of the impurity will remain. So let us call the initial amount of impurity, let that be A0. So for n equals 2, in the first pass we will remove 1 over n, amount of an impurity, or rather A0 over 2 of the impurity. That's the amount that will be removed. Amount removed. Next, it will be A0 over 2, so the previous amount over n, so A0 over 4. Next, it will be the previous amount, A0 over 4 over 2, which is A0 over 8, etc., etc. So then, if we keep doing this forever, the amount that will be removed is the sum of all of these terms. So the total removed is the sum of all of these terms, which is A0 over 2 plus A0 over 4 plus A0 over 8 plus, which is actually the sum to infinity of a geometric progression. And we know that the sum to infinity of a geometric progression is A over 1 minus r, where A here is the first term, so A0 over 2, and r is the common ratio, which in this case is 1 over 2. And then once you work this out, you should see you get A0. So the total removed is A0, which was the exact amount of impurity we had in the first place. Therefore, the water can be made arbitrarily pure for n equals 2. Now, if we do exactly the same thing for n equals 3, what do we guess? So after the first pass, we remove A0 over 3. After the second pass, we remove A0 over 3 squared, because each time we remove 1 over n from the last amount. Next would be A0 over 3 to the 3, because again we're removing a third of what we removed last time, and that would continue forever. So again the total removed would be a sum to infinity, and in this case the first term is A0 over 3, and the common ratio is 1 over 3. And what we find is that this is A0 over 2. So the total removed, if we continue like this forever, is A0 over 2. What does that mean? That means that there must always be at least half remaining.